Okay, so today we're going to be talking about titration. Now, what titration is basically neutralizing an equation between its acids and bases. It's neutralizing those acids and bases that are within the equation. So the first thing that you do if you have a titration problem is you're going to write out the equation and then you're going to balance it. So in this case, a 15.0 milliliters of 0.5 molarity of NaOH is used to neutralize 25.0 milliliters of HCl. What is the molarity of the acid solution? So for this, the equation is going to be HCl plus NaOH produces H2O plus NaCl. Now the first thing that we're going to do in order to get to finding out the molarity of the acid solution is we're going to plug in NaOH into our equation molarity equals mole over liters. So what we're going to do is, since we have enough information to plug in NaOH, that's what we're going to do. So that would be 0.50 molarity equals mole over, and since it's supposed to be over liters, we're not going to put 15.0 under here. We're going to say 0.015 liters, because we have to convert that to liters, equals, which that is going to equal 0.0075 moles of NaOH. Now the next step we're going to take is we're going to convert these moles to moles of HCl. And how we're going to do that is we're going to take the moles, 0.0075 moles of NaOH, and we're going to multiply that by 1 mole over HCl divided by 1 mole of NaOH. Now, these two numbers, the 1 mole and the 1 mole, come from the ratios from either reactant to product or reactant to reactant. So, since this equation is all 1 to 1 to 1 to 1, the ratio between HCl and NaOH is 1 and 1. So that's where these ones come in, and then NaOH is going to be at the bottom because we're going to cancel that out because we want to get HCl moles, not NaOH. So this is going to be 0.0075 moles of HCl, because we really didn't do anything with this number, since if we plugged it into the calculator, let's say, it'll just be multiplying 0.0075 by 1 and then dividing it by 1. So we're going to get the same answer. So now we have the moles of HCl, which is 0.0075, and now we can go ahead and plug that back into our first equation we used, which was molarity equals mole over liter. Now, we're not going to plug in the molarity because that's what we're trying to find. So the equation is going to look like molarity equals 0.0075 moles over 25.0 milliliters. Now we're going to have to convert that to liters once again. So it's going to be 0.025 liters, which is then going to equal 0.30 molarity of HCl. Now before you submit your final answer, the first thing that you're going to want to do is make sure that you have the proper amount of sig figs. So 0.30 has the same amount of sig figs as 0.50, which 0.50 has the least amount of sig figs in this whole problem. So then this has the proper amount of sig figs, therefore you can consider it your final answer. Okay, so we have our second example. A volume of 30.0 milliliters of 0.25 molarity of HCl neutralizes a 50.0 milliliter sample of KOH solution. What is the concentration of KOH? So once again, the first thing that we're going to do is we're going to write out the equation and then we're going to balance it. So for this problem, the equation is going to be HCl plus KOH produces KCl plus H2O. Now once again, this equation is already all balanced out. The ratios are 1, 1, 1, and 1. So the next thing we're going to do is we're going to use that equation again. Molarity equals moles over liters. And we're going to use HCl because that's what we have the information for. We have its molarity and its liters, so we were able to plug it in. So we're going to take 0.25 molarity equals moles over, we're going to have to convert this to liters once again, so it's going to be 0.030 liters, and that's going to equal 0.0075 moles of HCl. So we're going to convert these moles of HCl into KOH, moles of KOH, and remember we're going to do that by taking 0.0075 moles of HCl and multiplying it by its ratio to the other reactant, so that's going to be 1 mole over KOH divided by 1 mole of HCl, because we're going to cancel that out, which equals 0.0075 moles of KOH. So we're going to take these moles and plug it into this equation once again, so that we can find the molarity of KOH, because now we have its moles, which is what we need, and we have its liters, which is what we need. So we're going to take molarity equals 0.0075 moles over, we're going to convert this into liters once again, so it's going to be 0.050 liters, which is then going to equal 0.15 molarity of KOH. Then we're going to check for sig figs once again. So it matches up with these two sig figs, two sig figs, two sig figs. So then this will be the final answer.